Alright, we're going to do lesson 57, phase shifts in sinusoids and periods of a sinusoid. So let's start out with a little review about sine and cosine curves. This is a sine curve. We know it because it intersects at 0, 0, because we know the sine of 0 is 0, we know the sine of 180 is 0, and we know that the sine of 90 is 1, the sine of 270 is negative 1. So that forms our sine curve. Now this has an amplitude of 4, so if we have the sine of 90 is 1, it would be multiplied by 4. This is also a sine curve, but you see how it's going downhill first? That's the reflection. So we have to have a negative, and we see our amplitude is, here's negative 3, our amplitude is 3. So that's why we have, it's a reflection, it's going down first instead of up first. So we have negative 3 sine of theta. Our cosine curves, when theta is 0, we would get 1, but it's multiplied by 2. So we have 2 cosine of theta, because that's our amplitude, and cosine starts up and then goes down and then back up. This one has a bigger amplitude, you can see, and it's going to go, instead of being up here, it's down here, so it's reflection. So it has to be negative, it's reflecting over the x-axis, and the amplitude's 4. So that's it for our review. Let's hit some problems for our new ones, our phase shifts. I tried to draw these in, but I'm a bad drawer, I'm sorry. This is the new curve, this black one right here. If we compare the black curve with, the red one is the normal sine curve. It starts here to 0, 0, and then it goes up to 90 at 1, then it hits 0 at 180, 270 it's negative 1, and back up to 360. If we just talk about it, what happened to it from, if we're talking about this curve as being a sine curve, how did it go from the red to the black? Well, this is the normal sine curve, the red. This is our new one, is the black. And what it did is it moved to the left 45 degrees. And if you remember, anytime we do horizontal shifts, it's the opposite. If we went in the negative direction, it's going to be positive. So if we're going to rewrite this as a sine curve, we would write y equals, and the amplitude is 1, so we don't have to worry about that. It would be sine of, instead of just being theta, it moved to the left 45 degrees, so we would say plus 45 degrees. We're going to be able to write these as sine and cosine curves. Now look at it. The blue is our normal cosine curve. If we look to see how this curve varied from the black curve, you're going to see that it moved over from the peak to the peak, right here, this peak, 45 degrees. It moved to the right 45 degrees. So here would be where a normal cosine curve would be. Here's our new cosine curve. It moved to the right 45. So we would say y equals the cosine of theta, and when it moves to the right, you subtract. So you can see we can write this either as a cosine curve shifted or a sine curve shifted. You're going to see that often, and you're going to get, if you plugged in values, it works the same for both of these. So let's look at this little diagram here. This is your phase angle. It moved from, if you think of the normal sine curve, it starts at 0, and it moved, for the sine curve, you talk about where it moved from, well, it's going to be from the bottom or the middle to the left. When you're talking a cosine curve, the cosine curve, you would start at 1 to the right, is where it moved. So the sine curve, you look down by the x-axis. The cosine curve, you look up by the 1 to see how it shifted. So let's try an example. Write the equation of the sinusoid shown here as a sine curve with a phase angle and a cosine curve with a phase angle. So you could sketch in what a sine curve would normally look like. Wouldn't a sine curve start with 0? Here we have this amplitude thing going on too. So a sine curve is typically 0, 180, can't even find 180, and 360. I can't read the writing here. So a normal sine curve would look like this: up, down, and up. So we look, remember the sine curve, we're looking at how it shifts along the x-axis. So it's shifting, our sine curve has shifted over from the normal curve, it's shifted to the left, and I think that says, I can't really read it in there, it's 60 degrees. So if we're going to write a sine curve, we would write y equals, consider your amplitude, so 4 to 6 would be 2. There's even more we have to learn about these. It's going to be the sine of theta. We moved it to the left 60, I think that is, so it would be plus 60. We can also write this as a cosine curve. Remember, our cosine curve is going to start up here at the top and is going to come down and hit 90. So it's going to come this way. So we looked at how, we have to look at how it shifted from the y-axis to the peak of the first hump there. And it shifted, if you look straight down here, it shifted 30 to the right. So our cosine curve is going to be y equals, the amplitude again is 2, cosine of theta minus 30. So see how it moved from this point, from the top. We always do our cosine curve from the top to the top, and we do the sine curve from the axis to the axis. Okay, let's try something else. I think that's it for examples. There's another example that I didn't do in your book if you want to look at that example too. Let's move on to the next, even more complicated thing with these curves. Here's the sine curve. You can see it has shifted. If it was supposed to start at 0, 0, right here, it shifted 45 to the left, so we have plus 45, and the amplitude is 2, so we have the 2 there. You can measure a period in a graph. A period is from one hump to the next is a period. I'm sure they have a better definition. A period is I'm looking for the definition in the book, but I'm not seeing one. So let's see. So this would be from 0 to 360. This is one period. It's going up. If it would have started here, it would have went. What a normal sine curve that we look at, that's one period. It goes up. Let me just draw this here. And it would come down to -1 and back to 360. A period is the space that it takes to complete one whole cycle. So it's going up, down, and up would be a period. Now, our periods can change like this one. I know it's hard to see, so let me try to write it in. This is y equals sine of 2 theta. What that is telling us that there's 2 cycles that repeat in the 360 degree range. So what this number is the number of cycles or number of periods that happen in 360 degrees. So this one went up, down, that's 1, up, down, well let's see, it went 2. So it had 2 complete cycles, so we make it 2 theta. This one here, let's look at this. This is 360 degrees right here, and we see how many cycles it completed in 360 degrees. So this one went 1, 2, 3, 4 cycles in 360 degrees. So that's why this one is y equals sine of 4 theta. And let's just look at one more. Here's 360 degrees. I'm having trouble seeing what 360 degrees is. My drawings are a little fuzzy. 360 degrees is at the bottom of this first hump right here. This is our 360 degrees. So this one doesn't even have a full cycle. It actually takes double the amount of time to complete a whole cycle. So this is a half a cycle. So this is the same as y equals the sine of half theta. It only got half a cycle in 360 degrees. Alright, let's try some problems here. Well, one more thing. We're going to be writing equations of curves. So what you have to figure out is to figure out this coefficient k right here. You take 360 degrees and divide it by the number of periods. So here's our curve with number of periods in 360 degrees. So let's see, we have 1, 2, 3, 4 periods. So we would take, to figure out this k value, we would take 360 degrees and divide it by 4. Oops, the period in degrees. So it would be 90. Sorry about that again. So it would be 90 degrees would be 1 period, and so that ends up being 4. Most of the time you can just count them, but occasionally you can't count them, so you have to use this formula. So the period is 90 degrees, 360. If you have it in radians, you put 2 pi on the top, and then you put the number of radians to complete 1 period. So this equation right here, you can see the center line is 10. We haven't dealt much with the center line. So we get y equals 10 plus 2 is the amplitude, sine of 2 or 4 theta. You take whatever one cycle is, that's 90 degrees, into 360, and that tells you what coefficient to put in front of the theta. Let's try some more of these. I didn't really do a lot of examples here. Okay, we're writing the equation of the given curve. This is a cosine curve because it starts up here. The center line is -10. So when we write the curve, we're going to get y equals -10 because that's the center line. We're going to combine all these shortly, where it has a shift, it has a change in period, and it has the amplitude, and it has a center line that's not 0. So this one, the center line is negative. We have our amplitude is 3, from -10 to -7, so that's going to be 3. It's a cosine curve, and now we have to figure out what coefficient we're going to put in front of our theta. So we're going to have to figure out our k. This is in radians. So 1 period goes from 0, it's from hump to hump here, to pi. So when it's radians, instead of being 360 divided by the degree, it's going to be 2 pi, or it's going to be pi divided by, 2 pi, because it's 2 pi, that would be the same thing as 360 divided by pi. So your coefficient is going to be 2. So you would just put a 2 here. So hopefully that made sense to you, and I'll be able to explain this more in class tomorrow.